Normal distribution. What did we work on yesterday? You remember? I know. Standard deviation, right? Yesterday we learned a couple of things. I'm just going to tip this over. That this guy stands for the mean, and its name is mu. So if you hear me say mu, I'm referring to this symbol, which is the mean. Mean is a fancy name for what?
Middle.
Average. But it's our center of data, yes. So I like how you said middle. That correlates for sure. And then we've got a new symbol, that guy. Does anybody recognize what that means? All right, so that is standard deviation. And it is sigma, is the name of that Greek letter, okay? So we've got mu and sigma, and we're working with mean and standard deviation. So we spent some time yesterday calculating standard deviation, and the formula looks scary, but was it not too bad, I hope? Okay, it was calculator work. That's really what it comes down to. If you miss something, you kind of get frustrated, but you know you can go back and fix it, right? So today we'll apply what standard deviation intends. You recognize that symbol right there? I'll zoom in. Yep, that's our mean. And then notice, as we go from the center there, Braxton, like you said, or middle, I'm either adding or subtracting one standard deviation to get me to this point. And then to get to this point, what am I doing? Adding or subtracting 2 standard deviations. And then from here to here, adding or subtracting 3 standard deviations, right?
Standard deviation basically just X.
Standard deviation is a measure of how far are we away from that mean. So if I were to fill this in with water, does that segment hold more than this segment over here?
Yes.
Why?
There's more volume.
There's more volume, right? And so what that's actually telling us in these percents, sorry, I'll put that right back where we can see it. Those percents, that's what it's expressing. Between 1 standard deviation away on either side, how much of your data falls in that window? 68%. Once we do a story problem, this will start to make a little bit more sense, but I need to show you what this means. 2 standard deviations away. How much of your data falls within 2 standard deviations? 95%. Within 3 standard deviations, almost all of it, right? So we'll have some outliers or some high maximums or minimums that would make up that remaining 0.3%. So let's show you how this works. They were nice, and they have calculated the stuff for me. You're not going to have to calculate the standard deviation. But there are some key pieces of information you need to look for out of these story problems. The batteries from a certain manufacturer have a mean life. That sounds important, doesn't it? Mean lifetime of 810 hours with a standard deviation of how many? 90. Assuming their lifetimes are normally distributed. And I should clarify, not all data has a normal distribution, but that's what we're going to focus on. Grades usually fall this way. We expect the majority of our students to be somewhere in the C, low B range. And then we've got A's and B's and D's and F's. So it's just kind of saying the majority of your information falls in that center area. Exactly why it's called grading on the bell curve. Because maybe the majority of my students I don't want to give a C, so I'm going to adjust that and say it's a B from there up. Yeah, no, that's a great question. Now, I'm going to use this guy. I would probably use this guy for my homework too. So I'm just going to put pencil marks in here, and then I'm going to probably go back and erase it for my next story problem. I'll show you what I mean. The mean is 810. That's what I'm going to put right here. It's 810. And then it says I have a standard deviation of 90. So if I'm going one standard deviation away, this battery lasted for 810 hours. One standard deviation, those batteries lasted for 900. See how I just added 90? So let's take away 90 on the other side. That would be 720. So 68% of my batteries have a lifespan of between 720 and 900 hours is how we would read that. Okay, let's fix this though. So 900 plus 90 is 990, and then 3 standard deviations would be 1080. Take away 90 from 720, we got 630. Take another 90 away and we get 540. So I just want to make sure before I move on. Can you guys see that I'm just adding standard deviation values and subtracting, right? Okay, so now we can answer our question. Approximately 99.7 of the batteries have lifetime between. Do you recognize that 99.7 from anywhere in that chart right there? This guy right there, right? So I'm going to look at that window. 99.7% of my batteries have a lifespan between what? 540 and 1080. Next question. Approximately how many of the batteries have lifetimes between 630 hours and 990? So you looked at this window right here, and you went up and you said, oh, yep, that's 95%. Love it, Mallory. Thank you. How do you feel about that? All right, let's do it one more time then. At one university, the mean distance commuted to campus by students is 17 miles. So I'm going to erase this information. I should have written lighter. But it's sure nice having that all lined up for me. So there's 17. And it says a standard deviation of 4.3. Add 4.3. $21 point what? Add 4.3 again.
25.6.
Good. Add 4.3 again.
29.9.
Whew. All right. Now let's take away 4.3.
So is that always going to be one of these percentages?
Yes, today it will be. Absolutely it will be.
What's that last number?
29.9. All right, 17 minus 4.3.
13.
12.7. Yeah. Take away 4.3.
8.4.
Take away 4.3. 4.1. Okay. Approximately, how many of the students have to commute distances between 3.7 and those don't match up, do they? I'm going to have to fix this. So we're going to say this is 4.1 and 29.9. I have a typo here, obviously. 4.1 and 29.9. How many is that? 4.1 and 29.9 would be 99.7%. Approximately 68% have commute distances between what? 12.7 and 21.3 miles. I love it. How do you guys feel about this? Good. Let me open your homework assignment for you. Were you able to finish yesterday?